Hi, this is Mark Roth, and this is Mathematics for Social Justice. This video will be on counting permutations. Now, when we count permutations, we're going to do it in a more sophisticated way than what's usually taught, say, like in middle school. In middle school, if you wanted to have a permutation of the numbers 1, 2, 3, 4, 5, you could just write like 1, 2, 3, 4, and 5. And just mixing up the order would be a permutation. Of course, you don't have to mix up the order. 1, 2, 3, 4, 5 is also a valid permutation. We can call it the identity or the normal. But when you get into higher math, permutations are usually done as functions. And so let's introduce that. So we could have this situation where functions take inputs and give you outputs. So we could have 1 goes to 5, 2 goes to 2, 3 goes to 1, 4 goes to 3, and 5 goes to 4. So we have, input, output. So this is a more sophisticated way to show this same permutation. There's another notation called cycle notation. Since 1 goes to 5, we write 1 like this on the side of 5. So it tells you that 1 goes to 5. And then 5 goes to 4. And then 4 goes to 3. And then 3 goes to 1. Oh, excuse me. So then what we do is we put a line there. So 1 goes to 5, 5 goes to 4, and 3 goes to 1 means it goes back to the first one. And then the other number is 2. Notice that 2 goes to itself. So mathematicians would often write it like this. Another way to write it would just be 1, 5, 4, and 3 without writing the 2, because it's just understood that if a number is not shown, that it goes to itself. We're going to look at different conjugacy classes. And so, for example, there might be other permutations where you have one number going to a second, and then the second to the third, and the third to the fourth, and the fourth back to the first. And then this fifth thing just goes to itself. So this would represent a whole class of functions. And it's interesting to count, how many of each kind of class there is. So let's start real easy. Let's start with 3 items. So let's say we're starting with 1, 2, and 3. One thing you can do is just have everything go to itself, and that's called the identity. You could also write that like this. 1 goes to itself, 2 goes to itself, and 3 goes to itself. So there's only one identity. So then what about if you have a number A going to B and B going back to A, and then C just goes to itself? And let's not even bother writing the C, okay? So this is actually called a transposition, when these two just switch places. So here we have A going to B and B going to A, and C going to itself. So how many of those are there? For example, you could have 1 going to 3. That's no different than 3 going to 1, because it just tells you these two are trading places. 1 goes to 3 and 3 goes to 1. This is the same thing. If we want to list all the ways, you can have 1 and 2 transposing and 2 and 3 transposing. So we're getting a count now. There's 3 different permutations. There's 3 of these. And then how many of these can you have? This tells you that A goes to B, B goes to C, and C goes back to A. Well, there's 2 of those, because you could have 1 goes to 2, 2 goes to 3, or you could have 1 goes to 3, and 3 goes to 2. These 2 are not the same, because here you have 1 going to 2, and here you have 1 going to 3. They're not the same. But there's 2 in this class. So if we get a sum now, we get 6. Now that's not surprising, because when you have 3 things, the number of ways should be 3 factorial. And that's 3 times 2 times 1. So we were expecting 6. So we can feel good about ourselves that we got 6. So let's try going up a step. 1, 2, 3, and 4. And 4 factorial is 24. So we want to get 24 total in the different classes. So the identity is always 1. There's only one identity where everything goes to itself. There's one of those. Well, what if we have A going to B? And then C goes to itself and D goes to itself. How many of these are there? That's actually 4 choose 2. So this is simple for counting combinations. We're going to choose 2 things out of 4 possibilities. When you choose 2 things from 4, there's 4 things that you can select first, 3 things that you can select second, but you're counting each way twice because suppose you can count A followed by B. It's no different than B followed by A. And when you go 4 times 3, you're counting that twice, so you have to divide by 2. So in general, you would say, well, it's 2 times 1, so it's a combination. 4 choose 2 is going to be 12 divided by 2 is 6. Now, what about A going to B and B going back to A, and then also C going to D and D going back to C? How many of those could there be? Let me move this farther to the right. So we have 1 of these, 6 of these. How can we do this? How can we figure this out? Well, A has to be with something, and there's 3 choices. So when you figure out what goes with A, you're basically done because the other 2 go with each other. Okay, so what about A goes to B, goes to C, and then D goes to itself, of course. So if A goes to B, goes to C, how many of those would there be? First, you have to pick the number that you're not going to use, that's going to go to itself. There's 4 ways to do that. Then A is either followed by B or C, and there's 2 ways that can happen. That means this should be 8. Okay, so we're still not at 24. We're only at 18. We need something else. So there's another conjugacy class. Let's talk about A goes to B, goes to C, goes to D. How many of those are there? So A is in there. It's followed by one of 3 things. And then that's followed by one of 2 things. So that should be 6. So hopefully this will add up to 24, and we have them all. So we have 7, 10, 18, 24. So this is a good counting problem. We counted all the permutations of the numbers 1 through 4. So let's move on. Let's keep going. Maybe there's more to learn. Let's try working with 1, 2, 3, 4, and 5. And there's 1 identity. And how many of these transpositions? So A goes to B, B goes to A. How many of those would there be? Well, that would be 5 choose 2. And 5 choose 2 would be 5 times 4 divided by 2 times 1. That would be 10. So there should be 10 of these. What about A, B, C? Well, there's 2 numbers that each go to themselves. Okay? So they have to be selected, and that would be 5 choose 2. That would be 10 again. But then A has to be followed by B or C. So that would make that 20. We can stop for a minute and figure out what number we want to get as a sum. So that's going to be 5 factorial, which is 120. So we want all these numbers up to 120. So let's talk about A going to B, going to C, going to D. And then E goes to itself. So that would be 5 choices for what you don't use. And then A's in there somewhere. It's followed by one of 3 things. And then that second number is followed by one of 2 things. So that'd be 30 of those. Okay, so what about A going to B, C going to D, and E going to itself. Well, we don't have to write it. So first we choose the number we don't put into these two pairs, or these two transpositions. So there's 5 choices to not go here or here. And then A goes with one of 3 things. So that should be 15. All right, what else can we have? We can have A going to B, and then C going to D, and D going to E. How many of those could we have? Well, first we can choose these two. So that'd be 5, choose 2, that'd be 10. And then C's in there somewhere, followed by one of 2 things. So that should be 20. You can practice this during the video by just stopping and trying to calculate it yourself. So what else do we need to do? Let's see what we have so far, how close we are to 120. We have 35, 65, 85, 95, 96. We're 96 so more. We need 24 more. We can have A going to B, going to C, going to D, going to E. A is followed by one of 4 things, and B is followed by one of 3 things, and C is followed by one of 2 things. So that is 4 factorial, it is 24. So we do get 120. So we were able to do this count successfully. Should we go and do one more, or is that enough? So next let's try with 6 numbers. And 6 factorial is 720. So let's see if we can get to 720. And so we can start with the identity. There's one way to do that. We can start with transpositions. So when we're doing 6, choose 2, which is going to be 30 divided by 2, that's going to be 15. And when we try A goes to B goes to C, we start by choosing 3. That'd be 6, choose 3. And that's equal to 6 times 5 times 4 divided by 3 times 2 times 1. Because the reason that works is first you choose 1 out of 6. And there's 5 remaining ones to choose second. And 4 remaining ones to choose third. But when you count those, there's 6 different ways to arrange those 3 choices. So we have to divide by 6. So that's going to be 30, 120 divided by 6. That's going to be 20. Okay, so there's 20 ways to choose 3 of these. Then, once you make your choice, A can be followed by B or by C. So there's 2 choices after that, so that means 20 times 2 is 40. There should be 40 of those. Now let's try A, B, C, and D. So we're not using E or F. Okay, so there's 6 choose 2 ways to pick the ones you're not using. 6 choose 2 is 6 times 5 divided by 2. That's 15. Okay, and then A is going to be followed by one of 3 things. So we got 3 things to follow A, and then 2 things to follow B. So that's going to be 6. So I have to times 15 times 6 and get 90. Now let's try A, B, C, D, and E. Well, first you're going to choose the one that's not going to be used. And there's going to be 6 ways to do that. And then we have A followed by 4, followed by 3, followed by 2. So that's going to be 4 factorial. That's going to be 24. So 6 times 24 is the same thing as 12 times 12. That's 144. Now, what about this situation? A, B, C, D. Feel free to stop the video and try it yourself. But when I do it, I'm going to choose the two that aren't used. We're not going to use E and F, so that's 6, choose 2, that's 15. Now A is going to be followed by B, C, or D, so that's going to be 3 choices. So it's going to be 15 times 3, and that's going to be 45. Okay, so what about AB followed by C, D, E? We're not using F. F goes to itself. So that's going to be 6 choices for the F. And then there's 5 remaining. And we're going to choose 2 of those to go to each other. So that's going to be 5, choose 2, that's 10. And then we have to pick the order here. So C is going to be followed by D or E. So that's 2. So that's going to be 120. Okay, so next, let's try, how about AB followed by C, D, E, F. How many of those would there be? Well, we could choose these 2. That's 6, choose 2, that's 15. And then after we choose those, C is going to be followed by 3 things, and then 2 after that. So that's going to be 6. That looks like 90. Okay, so what do we have to do yet? We still have to do A, B, C, followed by D, E, F. How many of those are there? A is going to be with 2 things, and those 2 things are out of 5. We have to choose 5, choose 2 to find out which 2 go with A. So it's 5, choose 2 is 10. And once you choose them, A can be followed by B or C, so there's 2 choices. And then D is going to be followed by one of 2 things, so there's 2 choices there. So I believe that's going to be 40. Let me double check that one, because that one looks hard. So I said A is going to be there, and it's going to be with 2 things. So it's 2 things out of 5, and that's 10. And then B and C can be in 2 different orders. And then D is going to be in the other triplet, and it's going to be followed by 2 things. So I'm going to stick with that 40. So now we got to figure out if there's any more of these things to do. So we have A with B. We got 3, 4, 5. We haven't done A, B, C, D, E, F yet. So that's going to be 5 things following A, and then 4, 3, 2, 1. That's going to be 5 factorial, which is 120. Have we done all the conjugacy classes yet? Well, let's get a running total to see if we're missing anything. We're expecting 720. So this is 160 plus 90 is 250. And this is 55, 56. So these 3 are 56. And then if we add those 2, we get 200. And then 320, 410. So this here adds up to 410. So I forgot to add this 45, so that has to be added. So that's 455. So now I'm at 705. And I need to get to 720, so I forgot something. So I think it might be AB, CD, and EF. Okay. So Let's hope this turns out to be 15. So first of all, A's with one thing out of 5. All right? And so it's 5 choices for what goes with A. And then C hasn't been used, and there's 3 choices left. It could be with D, E, or F. So that's 5 times 3 is 15, and that does get us to 720. So the answer then would be 15. So again, this total was 455. This total now is 130, 250, 265. So let's add them together. We do get 720. So if you try this lesson with students, if you're a teacher, make sure that they understand what you're doing with these permutations. It's a little bit of a tricky concept for them to catch on when they're young. Like if you tried this with middle school students, be very sure that they understand what this is all doing.